All right, this is lesson 23.3, where we are going to be solving quadratic equations using the quadratic formula. So the quadratic formula will work 100% of the time, and it will be able to tell me what my solutions are if I have solutions, and then it will also tell me if I don't have any real solutions. So the first part of this lesson is just proving the quadratic formula, but we're not going to go through and prove it. What we're going to focus on is how to use the quadratic formula. So the quadratic formula, and if you don't have this written out, you should write it out in your math notebook. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it's really important that we remember that when we're solving quadratics, we're finding their x-intercept, so that is when y is equal to 0. So it's really important that we have our quadratic form in standard form set equal to 0. That way we know exactly what my a, b, and c are. If I have it in standard form set equal to 0, all then I need to do is identify a, b, and c and plug it into the formula. So let's practice this on the next page. Oops. Let's go back. So it says to apply the quadratic formula, make sure the equation is in standard form. So like I was saying, and set equal to 0. Identify the values of a, b, and c in the equation, and then substitute these values into the quadratic formula. One thing to note is if the expression under the radical sign is not a perfect square, we can write the solutions in simplest radical form or use a calculator to approximate the solutions. We're going to spend most of our time approximating the solutions with a calculator, but we will leave it as the radical form, and then afterwards we'll actually learn how to simplify radicals. So, example A is walking you through one of the process. We're going to do the try these. So now notice in try these A, my equation's not in standard form and not set equal to 0. So that's what we're going to need to do first. So remember, we want it in a x squared plus bx plus c is equal to 0. So that means we need to move the 4x plus 3 to the other side. So we're going to subtract 4x plus 3 from both sides. So that gives me 3x squared minus 4x minus 3 equaling 0. So now identifying a, b, and c. Well, a is 3, b is negative 4, and c is negative 3. So now plugging that into the quadratic formula, we get negative b, so negative 4 plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. Now we just need to simplify. Oops. So, and I'm just going to hopefully scroll. So negative 4, that would give me positive 4, plus or minus the square root. Negative 4 squared, negative 4 times negative 4 is 16, minus 4 times 3 is 12, times negative 3 is negative 36. All of that over 2 times 3, which is 6. So now I would just need to simplify underneath my square root sign. So that would be 4 plus or minus the square root. Well, 16 minus negative 36. That's the same as 16 plus 36. So the square root of 52 all over 6. Now I can simplify that radical, but I'm going to leave it as it unsimplified and then write my two solutions, and then we'll estimate what the square root of 52 is. So my two solutions are x equals 4 plus the square root of 52 over 6. And, oops, need an eraser. Oops. My hand marks. 4 minus the square root of 52 over 6. And then just plugging that into my calculator. So the square root of 52 is equal to 7.21110. So we'll just round that to 7.2. So we get 4 plus 7.2 divided by 6. So one of my solutions is about 1.86 repeating. And then the other one, so 7.2 is the square root of 52. So 4 minus 7.2 divided by 6, and then that would give me negative 0.53 repeating. So these would be my two estimated solutions. And again, you can leave them as the radical version, or you can simplify them with a calculator. We're going to do B next, but I need to clear this section. So if you need a minute to pause this and take these notes, then do so. If not, we're going to clear it. All right, going to B. Again, I need this in standard form, which again, remember, is ax squared plus bx plus c equals 0. So I need to get that minus 2 to the other side. So we're going to add 2 to both sides. So this gives me x squared plus 4x plus 2 equals 0. So that means a is equal to 1, b is equal to 4, and c is equal to 2. Now plugging that into the quadratic formula, so we get negative b, so negative 4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, simplifying, negative 4 is just negative 4 plus or minus the square root. 4 squared is 16 minus 4 times 2, which is 8, all over that over 2. 16 minus 8, so this would be, my solutions would be x is equal to negative 4 plus or minus the square root of 8, all of that being divided by 2, or we can simplify that by doing negative 4 plus the square root of 8 divided by 2 and negative 4 minus the square root of 8 divided by 2. The square root of 8, and I'm going to have a calculator, is about 2.83. So writing that off the sides, square root of 8 is about 2.83. So we have negative 4 plus 2.83 divided by 2. So that would give me about negative 0.585. And then my other solution would be negative 4 minus 2.83 divided by 2, which would be negative 3.415. So my solutions would be those two, or this in radical form. And you can separate it out as negative 4 plus the square root of 8 divided by 2, or negative 4 minus the square root of 8 divided by 2. Let me know if you have any questions. Again, the main part of using our quadratic formula is to make sure it is in standard form first, and then being able to correctly identify A, B, and C.